In this lesson, we're going to learn one of the capstones or foundation blocks, I guess, maybe for object-oriented programming, called encapsulation. So encapsulation is, depending on who you ask, two fundamental ideas that are closely related to each other. The first is that when you create an object or a class, that class should encapsulate or enclose all of the information for that class and its methods in a way that is transparent to the user. And then another aspect of encapsulation is this idea of having attributes and methods in the class that are of one of three categories: private, protected, or public. So we're going to look at how Python implements private, protected, and public. We're going to find out that it actually, in a lot of ways, doesn't implement those ideas. And if you're familiar with other programming languages like C++ or Java, this is going to be a really unfamiliar concept, especially in Java, where these ideas are very strictly enforced, and Python is very loose with these ideas. So let's go through and look at what private and protected and public means. So I'm going to create a class here that's going to have three attributes: public, protected, and private. Each one assigned to the integer 1, and notice that protected is preceded by a single underscore and private by a double underscore. That is how you indicate that you want a protected and private variable in Python. So there's not a command that says protected or private like there is in other programming languages. You just indicate that you want them to be protected or private by using a single or double underscore. Okay. For this private class, I have a string method. Notice it's preceded by double underscore, so private. And the string class just prints out the public, protected, and private attributes for the class in order. And then we have an add, which adds the private variable to the public. And one of the reasons why I'm doing that is to illustrate this idea that inside of the class, you can use the private variable any way you want, but you shouldn't try to, or shouldn't, well, I won't say shouldn't be able to, but you shouldn't try to access the private variable outside of the class. So going back up here to these definitions, which hopefully you were reading as I was talking earlier, with a private variable, only the current class can have access to it. If it's protected, the current class and any subclasses of that class will have access, and then public is wide open. Anybody can have access to it. And then here is another common idea for encapsulation with a private variable, is this idea of having a setter and a getter. The set sets the value for the private variable, and the get returns the value of the private variable. Notice that these are not protected or private, so anybody has access to these, which makes it look kind of strange, because supposedly this variable is private, but you have access to set it through the setter and access to get it through the getter. So in what sense is it private? If you can change it to anything you want and you can see what the value is, why is it then private? Okay, so that's one of the questions we want to answer in this example. So I've instantiated privacy, and then after I've done that, I have attempted to at least declared public to be 2, protected to be 2, and private to be 2. So I'm changing their values from 1 to 2, or trying to at least. Now, this is not considered to be good behavior. This is a protected variable, so you shouldn't be accessing it outside of the class. But in Python, you can. In Python, this is just a suggestion from the person that wrote the code that this variable is protected. So if you want access to it outside of the class, then you can go ahead and do that. It's just considered maybe not a good idea. The private variable, we're going to see something interesting here with this one when I set this equal to 2. So I'm going to run this code here without looking at the rest of the stuff. In this print command, I'm going to set print out example dot underscore double underscore private. And then I'm going to print out the example object. And so I'm going to take a look at what happens here. So when we do this, it prints out, why does this look like it worked? And we print out example.underscore private, which is 2. Looks good. well, or bad, because it's supposed to be private. We shouldn't have access to it outside of the class. So why is it saying then that it's 2? But then when we print out example using, remember, the string method up here, so it prints out all of this stuff, and it prints out the private attribute for the class. Notice that it says 1 still. So what has happened up here, when I set this thing equal to 2, it says 2, but now when I'm printing it down here, it says 1. Well, we're going to have to look a little bit more carefully at how Python implements private variables. Before we do that, let's just take a look at, I ran example.add, so add, remember, adds the private variable to the public. In this case, it's adding 1 to 2, not 2 to 2, but 1 to 2, so that double underscore private still equal to 1, and it gets 3. So again, it comes back to this idea of I set this thing up equal to 2 up here, printed it and got 2, but now it's behaving like 1 here, and it's behaving like 1 here. What's going on? Well, here's what's going on. When Python implements private variables, it uses something called name mangling. So you actually do have access to this private variable outside of the class, but when you do, you have to know the pattern for how Python actually names it. So we declared it to be, up here in the top, self._private. But what Python really did was create a variable that is underscore class name double underscore the variable we tried to create. So if I make this change, this variable exists, Python created it. Again, when we declared that variable up above, when I make this change and then print example, notice that private suddenly is 2. So this is what Python is actually calling this variable. So this is the Python philosophy. You can pretend to have private variables if you want, but in the end, if you know this trick and how the name mangling works, then you actually have access to it outside of the class if you really need to. So the Python philosophy on this is very different than other object-oriented languages that implement private variables where you absolutely have zero access to them outside of the class. Python says, gee, I think you're a good programmer. If you really think this is a good idea, then you can go ahead and do it. But it calls into question what happened up here. Well, what happened up here is you declared a variable to be equal to 2. Python said, well, I haven't seen this variable before because remember, it name mangled it to this name. So I'm going to create a variable and call it 2. So this equivalent to, I could have just said x equals 2. I'm basically creating a brand new variable here. And then I printed it and it said, oh, sure, that's 2. But it didn't change the value inside of the class because inside of the class, this thing is actually called that. Okay, now, coming back to this idea of the setter and getter, I'm going to do example.set5, and remember what that does. So example.set5 sets the private variable equal to whatever I pass in. So in this case, the private variable should be 5, and then I can also get the value of the private variable. That's because it just returns the value of the private variable when I do a get. And sure enough, down here, when I print out example, private is 5, and when I do example.get, I get 5 back. So this brings into question the idea of why in the world would I declare something to be private when I can go ahead and set it to be anything I want, and I can go ahead and get the value of it. What's the difference between this and being able to do something like this, which is not allowed? This looks a lot simpler. So why do I have to go through this set and get stuff? Okay, well, an example then of why this is actually a good idea. And this gets into the encapsulation. Encapsulation says, yeah, you shouldn't be setting the value of variables that belong to a class because that class may have other uses for it that you're unaware of. This is where the encapsulation comes in and the idea of private and protected variables. So let's take a look at a Tkinter example. Hopefully a relatively simple one. Create a root window, declare a string variable, and here see I'm using a setter. So I don't just say var equals 1, but I do a set. And the question is, why do I have to do this set with this var? When I've declared strings before in Python, I just said var equals and said 1. So why do I have to do this set command? Well, we're going to see here in a second. All right, so I'm going to put a canvas in the window with a background of red. I'm going to put that in row 0, column 0. I'm going to bind to that canvas the left button. So anytime I click on it, it's going to call this method. Well, actually, this isn't a method. I didn't even create a class. It's going to call this procedure up here. And I'm also creating in this window a label. And with that label, I'm associating it with this var, this variable. So whatever value this has, this will be printed on the screen. This is also a handy little technique to use when you're programming this label idea. You can see the value of your variables very easily, printing them on the screen, but that's a different thing. And I'm putting that in the second row. Okay, so what does click do? Click gets the value of var, which is a string, converts it to an integer, adds 1 to it, converts it back to a string, and then sets var equal to that. So that's a lot of work to basically say, I want to add 1 to var, which brings us back to the question of why do I have to go through all this work to add 1 to something? Why can't I just add 1? Well, the answer is here when you run the right program. So I'm going to run example, and I want you to notice what happens. So I'm going to click in this window with the left mouse, and that's going to call click. And when I call click, it's going to increment var by 1. Now, something happened here other than just incrementing the var by 1. It actually printed it to the screen. So I want you to think about that for a minute, because we've added 1 to variables before, but it doesn't automatically print them out. But in this case, when I change the value of var, it actually prints it to the screen. So adding 1 or changing var does more than just changing the value of the underlying attribute. It also calls other methods to make sure that the window is updated. And this is encapsulation, and why we do encapsulation in a nutshell, that changing the value of a variable inside of a class may cause other events to happen, and the class should know how to do that. The outside programmer may not. So when I increment this by 1, I don't have access to this variable. I can't update this thing. I could, but it'd be a lot of work. Tkinter takes care of that for me using the setter and the getter. Well, actually, in this case, just the setter. So this is encapsulation. Your classes should handle all of the work that needs to be done for all of its objects or all of its methods and attributes. And in this case, the var is one of the attributes of the window, and setting it handles not only updating the value to 2 or 3 or updating it by +1, but it also updates the screen, if that makes sense. So that's why we use setters and getters. Okay, now how does Python implement this? I'm going to show you another example using something called a property. So a simple example here where somebody has written a class student ID that just sets student ID to be whatever is passed in. And this is an optional variable, so if nothing is passed in, it sets the student ID to be a blank. And then we have a string method which just prints out or returns the student ID. And so there are 2 ways that one can instantiate student ID. You can instantiate student ID by passing in an ID, or you can instantiate a student ID and then you can set the student ID yourself using an equal sign. Student ID is a public variable, so there's no problem doing that. And so I have 4 examples here where I've implemented student ID. In this one, I'm passing in the ID, and this one I'm setting it as setting it myself. And down here, passing in, and in this one, setting it myself. And so if I run this, it does something very simple. All we do is we get Jim's ID, and it prints out his ID number, Jane's ID, and her ID number, Bob's ID number, and Roberta's ID, and her ID number. So it doesn't do a whole lot. But then I want to think about this way. So suppose that you've implemented the student ID class, and then somebody else writes some code based on that class. And then when they get done writing their code, they come back to you as the programmer and say, hey, wait a minute, I've written all this code, maybe it's hundreds of lines of code, and I realize you've got a problem because you let me set Jim's ID to be 1 through 9, but student IDs at our university have to start with a capital A, and it can only have 8 total characters. That's a problem. Now, what we need to do then is implement up here a method that checks that ID. No problem. We can write a method that checks that ID pretty simply. But we have another problem. We have all this code down here, and when we set the ID like this, are we going to have to now come back and change this code also to make sure that we check the ID? That's not really handy. And if this is a huge program, it's pretty likely we're going to miss places. It's going to be a lot of work. It's very expensive. Python takes care of that for us. So here's how this is going to work. We get a lot more code in the class. That's fine. The class should be transparent. The code down here is going to be exactly the same as what we had before, except for one little piece down here. So we need to look at the class code. All right. So up here, it's essentially the same, except for I've added a little bit here. I've got this check ID. Check ID checks the first character to make sure it's an A, checks the length to make sure it's 8, checks all of the characters after the A to make sure there's integers. And the way it does this is it goes through all of those characters using a for loop and tries to convert them to an integer. If it turns out that they were a character, this integer will fail, will throw an exception. That's why this is in a try except block. Also, if somebody tried to set the student ID to be something like a number that's not a list, this would fail, this index would fail. So this is all in a try except block, and if we get a value error or an index error is if this if it's not a list or a string, and the value error is if this is not an integer, then we return false. And again, the only way we get to be true, the only way we return true is if it has a initial A, length 8, and all these other things are integers. Okay, so I don't want to get into check ID too much. That was probably more of an explanation than needed. What's important is up here, if somebody passes in an ID into the init method, then we check it, and if it's valid, then we set the student ID to be whatever we passed in. Otherwise, we just set to be invalid ID. But notice what's going on here. This is a protected variable, so I'm not changing this to be a protected variable, but down below, I'm still using SID. So this is a really neat thing that Python implements. So I've got this check ID, but notice now that I also have getters and setters. Now, this getter does a print, and the setter does a print. Normally, you wouldn't do that, but I'm just doing this to sort of illustrate how they work. The get will print out the self.protected version of SID. Let's make sure I got that. Yeah, okay. And the setter is also going to do the same thing, print out the protected version of the student ID. And then it checks to set it. It checks the ID, and if it passes the check ID, it sets the protected version SID, and otherwise it sets the invalid, just like we did up above in the init. But then there's this new command. So I'm now declaring an attribute of this class, SID, student ID, and I call it property. And what this does is it says if somebody tries to set SID, then use the getter and the setter. And so it's going to make it transparent to the end user of our class that we have these protected variables. The end user is going to treat them as student ID because it has these built-in these getters and setters. They're never going to know that we inside have now created all this extra code for error checking. Their code down here looks exactly the same. We're trying to set Jane's SID, but when this happens, it's going to say, oh, you want to set an SID attribute for this class. Let me go up, oh, wait, I've got a property. That means I need to do the setter. And so when I do the setter, I'm going to come up here and check the ID and see that, in fact, in Jane's case, it's going to be invalid. So let's run this program and see what happens. So we print out Jim's ID, and we find out that it's invalid. And that's because we passed this in to the init method, and the init method did the check, and it checked and found that it was an invalid ID. No problem. Here's where this property method gets interesting. So we declare Jane to be of type student ID, but then we try to set the student ID to be this. And when we do that, again, Python says, oh, you're trying to set student ID. I need to run property. Property says, oh, you're trying to set the student ID, so let me run the setter method. See where it says setter right there? That's that. Then it prints out the student ID, but at this point, it's not actually equal to anything, so this was sort of pointless to print this out. Then it checks the ID and says, oh, check ID says that's invalid, so it sets the invalid to ID. Then, up here, now we're trying to we print Jane's ID, right? And then we print Jane ID using the string method. So we go up to the string method, and that says return this. Well, okay, that's what we set, so we're good. So inside, we're using the protected version of ID, but it's completely transparent to the user out here that we're doing that. As far as the user out here is concerned, we're using SID. That's encapsulation. Here, we pass in this ID. That goes to the init method. It checks it, finds out that it's fine. Again, we set Roberta's using an equal sign. That calls the setter. The setter checks the ID, says, oh, that's no problem. And then we print it out. We get the right thing. And then I want to do one more thing. I want to show you how the getter works. So in this case, I want to create a new variable, and I want to set it equal to Roberta's student ID. Now, you wouldn't normally do that with an ID, but I just want to illustrate something. When you do that, we need the value for student ID. So again, Python comes in and says, oh, you want the value for student ID, I need to run the getter. So it comes to get and returns the protected version. So the value here is, and then you can see where it runs getter and prints out the student ID. So the value here of encapsulation, this idea that I'm going to keep my information private to the class, and I'm going to implement the methods that work on this class, and I'm not going to let you know about it through this property method, is you can change the class up here. So I was able to add in this ID checking, and the end user didn't have to change their code. Everything works just fine, just like it did before, but now they have an extra level of protection or error checking, if you will. And so this is very similar to the idea that what happens over here with the Kinter and the string variable. So just one more time to recap, what I changed was I made SID protected, and then I used that protected version everywhere that I was trying to set the attribute SID. And then down below at the end of the class, I used this property statement. We're going to see more statements like this in the future, but this is our first example using the property statement. And that allows us to recreate the original attribute SID, but enforce it to be, in a way, private. Okay, there's a lot of information in this video, I think. And this idea of encapsulation there's a lot to it. So it may be worth watching this video more. It may be worth doing some extra reading on it. There's certainly a section in your book that would be worth reading. It's a really important idea for object-oriented programming, and this is the way Python implements it.